We have about 2 minutes left. 2 minutes left. If you are done early, I do want to push you to graph it on your calculator and then copy it onto your grid, okay? So you're done early. Okay. 40 more seconds. Go ahead and begin wrapping up. Finish up the problem that you're on. All right, that was time. Let me go ahead and get your eyes back on the board. I'm going to wait till I have 100%, just so I know we're ready to move on. So you can go ahead and put a pause to what you're doing. I do need your eyes on the board though. Still waiting on 100%. Still going to wait. Close it. Okay. So right now we're going to go over the questions. The expectation is that you're listening up here, you are silent, and that you're checking your answers with what you have here, with what's going to be on the board. Question number 1 there, Emiliano, give me your sentence. The graph is a blank blank by a factor of something. Again, everybody else is checking their work on the board silently.
The graph is a vertical stretch by a factor of 2.
Vertical stretch by a factor of 2. Class, do we agree?
Yeah.
Yes, good. Juan, why is this a stretch and not a shrink? The factor is what? Comparing it, it's bigger than. Do you remember from the key points? So there, again, it is a stretch because the factor is bigger than 1. It's a whole number. It's a whole number. So it's a stretch because it's a whole number. And in terms of the graph, in case you got to that part, it becomes a little bit more narrow or skinny. Moving on to the next one. 2 things happen here. Abby, help me out with the comparison there. In terms of the equation, g of x is something similar to the sentence up here. Vertical shrink. Again, we're checking our work on the board. Shrink by what factor? Factor of, I'll write in what you said, -1/2. Quick correction here. Stephanie Salas, what should we change?
The negative.
Why the negative? What do we say about the factor? It's just a number, right? It's just a number. It's just a number. So correct that on your paper. The shrink is 1/2. And Rosa, what does the negative tell us though? Yeah. G of x also reflects across the x-axis. So if you don't have this one down, write it down and just remember that the negative simply reflects the graph across the x-axis. Alright, now the graph. I know it was reflected, so it's going to be facing down, and it becomes more wide. So here is what the graph should have looked like on your paper. In case you got to that part. Now the last one, 2 things again. Go ahead and tell me the first one there, Destiny.
Oh, I hadn't got to that one.
You haven't gone into it? Let me go ahead and get help from William.
This graph is a vertical stretch by a factor of 2.
Thank you. Vertical stretch
No, it's a vertical shrink.
Vertical stretch. What did you say?
No, it's stretch.
Stretch by a factor of 3. And the negative there, Brandon, what does that mean? I have a negative in front, what does it mean? And a reflection across what? Reflection across the x-axis. So again, check your work up here. If you don't have this down, go ahead and write it. Across the x-axis. And again, this one was negative. The factor was small, so it became more narrow. Okay. So, right now, in order to not confuse you too much, I do just want to go over the key points again. That way it sort of sticks to you a little bit more. So go ahead and look at the board while I go over the rules one last time. Marla, I don't work. So, here, ultimately, yesterday we learned where you have a graph in this form, y equals x squared. And we learned where you have a number in front of the function, y equals ax squared. We learned about something in the front. It could be a whole number. It could also be a fraction. Take it to my question. And your attention on the board. So the number here could be a fraction or a whole number. When it was a fraction, it was a shrink. When it was a whole number, it's a stretch. And again, class, when you have a negative, what does it do to your equation?
Reflection.
Anytime you see a negative, reflection across the x-axis. That's just a summary of what we were doing yesterday. Simple enough, though? Okay, right now, go ahead. I'm going to give you 20 seconds to have out your notes from yesterday, and turn to the page that I'm going to show you on there. We're going to finish the notes. Go ahead, 20 seconds. I'll show you on the board what page that was on. Period 3, we're talking about now the horizontal transformation. So go ahead on your notes from yesterday, turn to this page right here. Key point number 3. You have about 10 seconds left. 10, 9, go for it, quickly. 8, 7, 6. Brandon's ready to go. Angel's ready to go. 3, 2, 1. Good. Thank you guys for being ready. All right. Here's going to be sort of the new thing that we have yet to learn that I did not go over yesterday. All right. Starting now, we're going to go over the notes. The expectation is that we're silent, we're sitting up, looking at the board, and taking notes along with me. So, in this case, we are now learning about instances where the change is happening inside of our parentheses. So the easiest way to remember this is that whenever you see parentheses, the transformation is going to be horizontal. So whenever you see parentheses, think the transformation will be horizontal, no matter what. And there are two scenarios here that we have to talk about. When a is bigger than 0 and smaller than 1, you have a fraction. I want you to write this down just so you remember. Above this bullet point here, key point number 3, write this down. When a is a fraction, the graph is going to have a horizontal stretch. A horizontal stretch. Do you see that there? Whenever you have a fraction, it's going to be a horizontal stretch. Write that down. Whenever a is a whole number, the next one, when a is a whole number, you have a horizontal shrink. Do you see that from the notes? Now, ultimately, going back to yesterday, the correct way to explain it, you must say, it is a horizontal stretch or a shrink, but by a factor of, and then you include the factor. So I want you to write that down on your notes, just in case you forget, because the correct explanation must also include your factors. So right now, go ahead and write this on your notes. by a factor of blank. All right. Now yesterday, whenever we talked about the factor was whatever number was in front. So if I had, for instance, y equals 2x squared, we would say that the factor was 2, right? Make sense? Now today, it's going to be different. We're talking about something with parentheses, and the factor that I have there is 2. Now, the main thing that I want you to remember, that we're still going to probably have trouble with, even after I tell you, is that the factor that you write is going to be the reciprocal of whatever number you have there. So here I have a 2, but I'm not going to say the factor is 2. I'm going to say it's going to be the reciprocal of 2. Raise your hand if you can tell me what it means to do the reciprocal of a number. Raise it silently. Think about it for a few seconds. Reciprocal of a number. We've talked about it before. We've talked about it with perpendicular lines in terms of our slope. Does anybody have an idea? Thank you, Evelyn, for being brave. Tell me. Into a fraction, yeah. So how can I turn this number into a fraction? 1 over 2. Class, do we agree? Yeah, so ultimately, my factor is going to be the reciprocal. So if I have a 2 there, the factor that I'm going to say is going to be the reciprocal of it, 1/2. It's okay if you don't understand that right now. We are going to do an example, which is good. That way you know how to do this. So take a few seconds, finish writing your notes if you haven't already, before we move on to the actual example. Okay. Let's move on down to the example. We're going to do this one after class. Again, work on it with me. Take notes along with me. Here I have an equation, n of x equals negative 1/4 x to the power of 2, and I want to compare both graphs. We're going to start here. We're going to graph the parent function x squared. If you have your notes from yesterday, there is a chart on there already that tells you all of the points of the parent function. You may use that, but in case you already memorized it as well, the points here for the parent function, let's graph it together. 0, 0, do that now. 0, 0. Then we have also 2 and 4, since it's going by 2s, 2 and 4. And we can plot those 3 points for our parent function, and then draw our line to them. And just like you guys have names, this equation also has a name. What is it called there? X squared. What is the name of this function? Class. And what's the name of this equation here? X squared. We call it what's in front. F of x. Because we are going to have 2 graphs there, we have to label each of them. So the first one, the parent function, f of x. That's what it is. Now our goal is to graph the other equation down here. So now that you have your calculator, go ahead. You're going to first graph this on your calculator and then open up the table. So go ahead on your calculators, begin graphing the equation on there, and then open up the table. You open up the table by pressing Control T. Pressing Control T, yes. So again, graph it on your calculator, open up the table, and then begin filling out the table that you have there on the left side. So look at your x values. So just graph it on your calculator on the document. Okay, assuming you have done that much, now Let's go ahead and put out the table together. If you found -8 already, go ahead and give me your answer there, Mariana. The y value there for that one? 4. The next one, Marlo. Were you able to graph that one? You haven't seen the table yet? Go ahead and help me out there. -4 and 1. Evelyn? 0, 0, 0. And then, if you guys have seen the pattern there, we're just going to go back up again. Like, it just repeats after you're at the lowest point there, the vertex. So, the next one, what would it be there? And then, and finally, the last one. What was the y value there?
4.
So 4, 1, and 0. Okay. I do want to teach you guys a little trick there. So, because I just want you to be efficient with this. Go ahead and pause what you're doing and look at the board. Genesis, Angela. So here, right? Ultimately, we're still graphing. And we're filling out the table. Now, sometimes you're going to come across decimal points, right? A lot of you saw decimal points here. Would it be sort of like smart for us to try and plot this point with a decimal? That's going to take too much work. So what I would do is plot the easy points. 0, 0, very easy. -4 and 1, fairly easy. And then, just draw a line through the points. So don't make it too hard on yourself. If you have decimal points, don't try and plot them. Only do the easier ones. So let's go ahead and plot this graph on there. You guys know how to do this. Plot the points on the graph now. So 0, 0 was a good point. 4 and 1. And look up when you are done. This is sort of what your graph should have looked like. If you don't have it down, go ahead and copy it. But again, this is what this graph should look like when you graph it on the grid. And the name of this one, we know n of x, and we're going to label that. Just so we know what graph is which. So again, when you're done, go ahead and look at the board. That way you know you're ready to go. All right. Now, last thing. Actually compare what is going on in this equation. Comparing it from the parent function to the one that we just drew. So we're going to look at our notes and look for the factor that I have there. I know that inside the parentheses I have a -1/4. And in this case, Brianna, is this a fraction or a whole number? The number that I have inside the parentheses there. A fraction. A fraction tells me what, Selena? What type of horizontal transformation? Looking at your notes up there. Horizontal stretch. Good. So here, let's write it. N of x is a horizontal stretch. Let's go ahead and write this together on the notes. This is a horizontal stretch. And we have to say by what factor? By a factor of, this is going to be the tricky part. Angel, what would you say the factor is there? Thinking about what I mentioned previously. What do you think the factor would be? -4. Now, thinking back to yesterday, remember that we also had situations where our factor was negative? Did we say in our explanation, did we include the negative there? Yesterday we didn't include it, we're not going to include it again today, because we're just focusing on the actual number, the absolute value of the number. But yes, the reciprocal of 1/4 is 4, so that is the correct factor. Thank you, Angel. And the negative in this case, it's not going to change anything. Let me show you why on the board. A question that all of you should be able to answer. What happens when I multiply a negative number times a negative number? You get a positive number, right? Well, in this case, I have a negative inside the parentheses, and we're squaring it. We're squaring it. That means that we're multiplying it by itself 2 times. So no matter what, a negative times a negative will give us a positive. So the negative won't really mean much in terms of the factor itself. Comparing it to yesterday, where when you had a negative, it was a reflection. In this case, a negative won't really mean much other than like giving us the factor that we have there. Okay, that was it for the example in the notes. I'm going to leave this up here now, but you are now going to get some practice. There are 2 problems to work on. You're going to work on these silently and independently. You're going to have 5 minutes. Again, there are only 2 problems. You should be able to get these done. Use my notes, use my example. You have 5 minutes. Go ahead and begin. First step is to go ahead and try and graph it. Try and graph the equations. Like the urgency I see from Stephanie's table. Thank you guys for working silently. Try and answer the question first about the transformation and then try and graph it. But again, the main thing here is being able to actually explain the transformation. And we are talking about horizontal transformation, so in your answer include that. It is a horizontal transformation. Could be a stretch or a shrink. How would that change anything to reciprocal? Turns into a fraction. Put the 3 at the bottom. 1. So change it. Also graph the parent function. Probably practice that one. So what should we say this? Make sure they include both words like horizontal. Still about 2 more minutes. 2 more minutes. You should be moving on to the last question now. If you haven't already, should be on the last question. Make sure to answer the sentence.